Okay, hello everyone. We're going to start the lecture now. So if you want to be on the slides, I'm using zthings. So this is the link, zthings.com/Morty. So you can just pop it up in any device you have, phone, tab, laptop. You can be on the slides. You can post a comment if you want to ask for something and you're shy. And look at the slide at the same time. Okay, so it's going. So I'm going to start with an introduction to the lecture, to the course, so you have an idea. I hope that since there is a web stream for this, so it's better to strap up. Okay. Everyone can hear me properly, or do I need to raise my voice? Okay, I assume all's good. So I'm going to start with an introduction to the course. You'll have an idea of what we are up to, how we are arranging things, and then we go some introduction about the material in the second part of the lecture. So, just as a disclaimer, part of the slides presented in this course has been taken from previous lectures provided by Dr. Helen Pike and Dr. Lina Yao. And hopefully that we have improved them so to make things much better, easy to understand, and capitalize on the experience of the previous lecturers. So, for this offering, the teaching team, I will be the lecturer in charge. You can call me Morty. So, and you can contact me on my email. If you want to schedule a consultation, feel free to drop me an email and we can hold a consultation between 4 to 5 Wednesdays. I'm in K17, level 4, so we can book a room and have the consultation. Course administrator is Muhammad Ali. Also, this is his email. If you want to contact him in anything in regard to course administration, feel free to do that. We'll have some tutors as well to help in the consultation labs and in the marking throughout the course. Muhammad Ali, Cheyenne, and we're adding one more. And definitely everything is available on WebCMS. You can access it through the course website. So just as a background for Comp 9321, how it evolved to being data services. Previously, it was web application engineering. So generally, it was more about creating web applications. But throughout the evolution of software, services become more attractive. And hence, the course has merged into focusing more on the services and part on the data. So in general, it evolved from being web applications, building just web application, into focusing on the data aspects and how we can create a service to allow the consumption of this data. So mainly, it's now focusing on how to work with the data and how to allow this consumption of the data as a RESTful API. We're focusing on RESTful APIs in this course as the technique and the approach for publishing the data. So as the name of the course implies, it's Data Services Engineering. So there is a data component. So we're going to look at working with the data, so ingesting the data, manipulating the data, cleaning the data, visualizing the data. And there is services component. So we are going to allow the consumption of this data as a RESTful service. So you allow the consumers to consume your data, to benefit, to manipulate your data. You're relying on RESTful API principles. And there is an engineering component. Engineering in the sense of relying on the best practices, how you can actually work with the data, how you can actually publish the data. So in that regard of using the best practices, recommendation, the requirements that you can utilize in order to create your data service. So there is a practical skill in that regard in creating the data service. Hopefully we aim by the end of the course to achieve is that you learn how to access the data, ingest it from various external sources. So getting the data from several sources, might be sitting on a database, might be on a website, might be on a different service, a data dump. So we're going to learn how to ingest this data and prepare it, pre-process it in order to be able to benefit with it. So pre-processing the data, this stored data, and preparing it to be used by your service. And hence, you need to learn how to curate this data in terms of curating, cleaning, manipulating, visualizing in order to increase the value of your data. And in order to also apply later on some analytics onto the top of the data in order to increase its value by providing some analytics service on top of the data. We're not going to go deep into the machine learning aspects from the algorithmic part. We're going to just utilize it. So there is a machine learning component in this course, but it's not on the term of how you design a machine learning algorithm or you build it from scratch, but more like understanding it on the level of, okay, I know what is clustering. I know what I need to do in order to be able to use the existing libraries on top of my data in order to provide an analytics service. So it's not a machine learning course, but we are interested in the application of machine learning on the data in order to increase the value. So mainly also from our part as a data service course, we are looking at all these components from a service-oriented architecture lens. So we are going to have the service as our managing approach for the data. The assumed knowledge of this course is that we are not going to teach databases. So we assume that you're already familiar or already taken a database course, already comfortable with data structures throughout, like in your previous studies. You are confident in programming in Python programming language. Python is going to be the main programming language we rely on in this course. So you need to be confident in programming in Python because we are not going to teach Python. So being confident in programming, being confident with databases, data structures, these are the assumed knowledge. So supposedly throughout the prerequisite, you should be already satisfying these as long as you have taken the previous courses. But by any means, this is not meant to be an advanced course. So we are just starting with data services. So it's not like we're not gonna going in advanced level of data science or in general services and REST API services. There are other courses that you can take after this course in order to improve your knowledge, such as Comp 9322, if you're interested in the service component, or I don't know if Comp 9313 will be offered next term, but if you're interested in the data component and big data. So this is an introductory course for the material, and you can advance later on according to your interest. Are you interested in big data? So Comp 9313 is a good option. Are you interested from the service side? Comp 9322 is a good option. So as a global look about the course structure, so this is a 3-phase course. So the first phase is going to be working with the data. So in this phase, we're going to look at ingesting the data, cleaning and manipulating the data, or what we call data wrangling, and visualizing the data. So this is the first phase of the course. The second phase is building a data service. So taking this data that you have prepared already, clean and visualize on some level, and then build a service on top of the data to allow the consumption. So you're going to build a RESTful API server and a RESTful API client in the second phase. And in the first phase is the data analytic on top of the data. So you're going to apply existing data analytic tools in order to increase the value of your data in the third phase. Any questions so far? So now to the juicy part. You see that I've changed some things in regard to assignments, because in the course outline we have 2, now we have 3, due to the changes in the how we previously offered tutorials. Now we don't, so I had to split this. And according to the increase on the number of the students, previously we had group assignments, but now we reached over 300 students, so groups are not really an option now because it's hard to manage a large number of groups and mentoring for this. So instead of having 2 assignments, one being group assignment, now we have 3 assignments. Assignment 1 is going to be, so the assignments map to the phases. So assignment 1 is going to be about working with the data. So you're going to look at ingestion, cleansing, manipulation, and visualization. Assignment 2, also, this is the first one is worth 50%. Second one also worth 50%, about building a service. Assignment 3 is about data analytics, which worth 20%. We also have 10% for online quizzes, 4 to 5 online quizzes that will be available and announced in WebCMS. And we have the formal lab-based exam at the end of the term, which worth 40% of the mark. So the final mark would be quizzes plus assignment plus exam. There is no hurdle. So the final mark is the accumulation. As long as at the end the accumulated mark is passed, then you pass. If not, then you need to try again. So we accumulate all of these assessments to produce the final mark. Yep. Sorry?
What is open testing?
Yeah, so we announced for the quizzes online on WebCMS, and we tell you like, it's announced today, you have 3 days to do it. So you can do it on your own time. It's not gonna be quiz now, and no, you have 3 days to do it on your own time. Remember to do it. Quizzes are just to motivate you to follow up with the lectures in order to keep the knowledge in your mind and push you to go through the lecture slides. They are fairly simple as long as you watch the lecture recording and go through the slides. So don't, it's like free 10% as long as you follow up. So the assignments, this is the tentative schedule for this because we're still working out the availability of tutors. But in general, for assignment 1, the data ingestion, which was 50%, the release is week 3, and it's due in the end of week 5. Assignment 2, the data service, REST API, creating the REST API service, also worth 50%, to be released on week 5 and due on week 7. Assignment 3, data analytics, worth 20%, released on week 7 and due on week 10. There is also a bonus mark. So we have 5 bonus marks to be added on the assignments. So the addition of the bonus mark is not on the overall mark, it's on the accumulated assignment. So in general, assignment is 50%. So the bonus mark to be added, like the cap is 50, but let's say if someone take 10, let's say 10, 10, and 15, then they are missing 5 that they can utilize this 5% to reach close to the overall 50%. So what's the bonus mark? How you can get the bonus mark? It's like, as I mentioned, it's 5% to be added to the assignments overall with the cap of being 50%. So if you're really good and you get 50, 50, 20, then the bonus mark is going to be 0 because you cannot exceed 50% for assignments. But if you're like you have 10 for the first assignment, 50 for the second assignment, 15, sorry, for the second assignment, and 20 for the third assignment, so you will get the 5 bonus mark so that you'll get a full mark for the whole assignments. So we cannot increase assignment over 50. The bonus mark can help you with just compensating. How you can get this bonus mark is related to the activities we're gonna release. So we're gonna release activities every week that you can do on your own. So for these activities, if you add an interesting idea about doing the same activity with less complexity. So you figure out that actually I can make the number of line of codes less by this much if I do this and this, or if I use that, and you post that on, like you make a pull request on the GitHub repo because all the activities are on GitHub. So you can add your own version of the activity that's like make things less complex, improve things. So you can do this. You can like maybe you spot a bug in the code. You say, okay, this is not actually working, it's causing this and that. So you make improvement for the code or for the documentation. Also this counts. Adding new activities. So you look at, like, let's say we give you an activity to ingest data from MongoDB, from MLab, and then you think, okay, I can have a similar activity that ingests data from a different data source. Okay, I'm gonna make an activity about ingesting data from a website using Beautiful Soup. So you add a new activity, related activity, and then also you put it on GitHub, you will get the 5%. And lastly, which is something I encourage you to do, in the essence of helping your fellow colleagues, your classmates who are affected by the travel ban, in order to be able to follow up on these activities. So you can make a video for an activity. So you do the activity on your own time, and you record that in a video, and you enrich that with explanation. So this can help with students who are either taking the web stream or they are affected by the travel ban and not being able to attend some of the lectures, so they can watch this video and do the activity with you. Yep.
Is this a video an instructional video to show the watchers how to do something?
Yes. Mm-hmm. So mainly because in general, what again I'm going to talk about in a bit, which is the consultation lab. So all the activities are self-guided. You can do it on your own time. If you're stuck somewhere, you can come to the consultation labs. Muhammad Ali should have posted, or maybe we'll post this in a bit, the schedule for the consultation lab. We have one lab for each day within the week. So every day we have a lab, and you can just attend there and ask the tutor if you're stuck somewhere, and they can help you debug and go through that. So basically, for the students who are not being able to attend these labs or affected by the travel ban, they can watch these instructional videos, and they can go with these activities on their own time. So, and also I encourage you to use the WebCMS forum in order to ask questions, even answer other people's questions. So if you see that someone is saying that I'm stuck here, I don't know why is this happening, there is this error, and you've been there, done that, you say, hey, yes, I faced the same error, you can fix it by doing this, you're doing this wrong, you need to add that. So always feel free to help each other on the forum. We encourage this to have the learning community, and you can benefit from each other's experience. Any question about the bonus mark or the consultation labs? So again, I emphasize that for the bonus mark, it's going to be added on the assignments overall mark. So if you are getting 50%, the whole 50 marks for the assignments, then the bonus mark is going to be 0, because we cannot go over the cap of 50 for assignments. But it can help you with compensating the lost marks in assignments if you've done things properly in the bonus. And then also for the bonus mark, all these activities, it will be qualitatively marked. So in terms of, don't think that, okay, any video will get the full 5%, the full 5 marks. So it depends on how good it is. So it is good on the level that it's easy to understand. I will be looking at these videos in order to recommend one that's the, let's say, the best quality for the student to, let's say, to watch on their own time. So try to maintain good quality in terms of the additional, these activities or the additional activity you want to develop, because it will be qualitatively marked. It's not 0, 1, yes, you've done it, no, you have not done it, in order to get the full 5 marks. Okay, so this is the tentative schedule. It's subject to minor changes according to the progress during the course and the interest in some of the areas. So we might be shifting some things according to your comments and feedback. But in general, these are this is the schedule week by week. So in week 1, we're just introducing the course, and we'll be also introducing the general idea about the course and the general technologies that we're going to go through. And then we start with the data ingestion tomorrow. So there is not going to be a tutorial or like a lab in this week, but you can like prepare by being familiar with the technologies. The technologies we are going to rely on is, as I mentioned, programming language is Python. We're using Pandas for data manipulation and cleaning. We're going to use Flask as the framework, the REST API framework. You can be familiar with NumPy as well for as a library for data manipulation. So these are the basic technologies. You can like start with getting familiar with them, and then so that when the next week when we start with the lab activities or like the hands-on activities, you can go through rather than you start them working on the environment at that time. Week 2, tomorrow we're gonna start with the data ingestion. We continue in week 2 with the data ingestion, how you can ingest data from various sources, how you can on a level of pre-processing in order to integrate the data in order to maintain it on a single storage. So we're gonna look at sources like NoSQL databases, like MLab in our case, or MongoDB, accessing APIs, data APIs, CSV files, and so forth. In week 3, we're looking at data cleansing and manipulation. So data is not always as clean or as good quality as you wish it to be. So you need to do some pre-processing. You need to work on the data in order to increase the value or increase the quality of the data. Week 4, we are gonna do some data visualization. So we apply some of the existing libraries in order to visualize the data, in order to do some high-level analytics, understanding what it is, what you can use it for, what you can apply later on. And then week 5 and 6, we're gonna look at data services. So building a RESTful API, building a RESTful API client, some security aspects of REST APIs, and so forth. And in week 7, we start with data analytics. So we're gonna look at, okay, what data analytics means, what you can do, how you can apply existing libraries in order to increase the value of the data. So we have some examples in regard to classification, clustering, and so forth. And then week 10, we wrap up. We give you some examples about the final exam and so forth. By the way, I mentioned that the final exam is a lab-based exam, but that doesn't mean you're gonna do heavy programming in the final exam. It is lab-based, so you're gonna use a computer to answer the questions. There is parts of code, but it's not gonna be write a program to do this and this and that. No, it's not gonna go that deep in that regard, but I can give you a snippet of code and ask you, okay, what will this do? Or how you can do this, how you can change that, or write an algorithm that can help you with doing this and this and that, give you some data and ask you what are the steps that you can do for pre-processing and so forth. So you can use pseudocode or even code if you want, but you're not obliged to write a whole program to do this. Yep.
Is it a minimum pass mark for the final exam?
No. So there is no hurdle, no, there is no minimum pass mark for final exam. The final mark is going to be the accumulation of all the assessments. Any other question? So just like a general note for students affected by the travel ban. So if you're watching this video on the lecture recording, as long as you can be on campus by the 28th of February, then you are most than welcome to continue with the course. We deem that we have multiple discussions in regard to providing support online completely, and we find it a bit hard to maintain a good quality of support. So that's why we have the consultation labs, we have lectures that you can ask questions. So doing the course completely online, unfortunately, is not something that we are prepared to. That's why it's not going to be, we do not recommend that going that through all the course and being away. And additionally, there is a final exam component that you need to be actually on site. So if you are not confident that you will be on campus by the 28th of February, then you can explore other options in regard to taking the course later on. Check out the information in the coronavirus frequently asked questions website, and then you can even contact the Nucleus Hub in order to get information of what is possible to do. If you are affected by the travel ban, but on the level of currently you're in the self-isolating phase and you will be on campus by February 28th, then you can please prepare by watching the lecture recording, going through the material, doing the lab activities on your own time, and participate on the online quizzes. So this is what you can do in preparation. In regard to supplementary exam policy, sub-exams is only available to students who did not attend the final exam. So if there is any emergency that prevented you from attending the final exam, you need to follow the UNSW guidelines in terms of how you can apply for special consideration. So you need to have a good excuse for this, like medical or others, and you have a documentation for this excuse. So make sure that you have a documentation. You can contact the special consideration unit within 72 hours so that they can give us, because they are going to be the ones evaluating your request, and then they will inform me as the lecturer in charge as, okay, we have granted special consideration to the students and so forth. I'm not responsible for granting special consideration. It's completely the special consideration unit job. So I'm just gonna receive their decision and according to this provide the sub-exam. It's not my job to decide. So please keep that in mind, that if by any chance something happened, there is an emergency, try to have a documentation and apply to the sub-exam if needed. Please go through the student conduct in regard to what's the university rules in this regard. And especially for my side, it's also, I just want to remind you in regard to paying attention to plagiarism acts. We use code plagiarism detection tool. So make sure that if you are uploading your code to GitHub, that you put your code in a private repo. It's not an excuse saying that, oh, I forgot and I've put it publicly available, someone find it and copy it. You are also going to be penalized, even if you've done it like in good faith. Oh, I forgot. Forgetting is not an excuse. We are just reminding you, you've put your assignment in a private repo. After the assignment, you can make it public. It's up to you. But as long as the assignment is not, the submission is still in action, like it's still, students can still submit the assignment, the repo should be kept private. You will be penalized if we detected that there is a plagiarism, someone copied you, so both parties are going to be penalized. So please pay attention to this, because it's like previously we had these cases of students forgetting and putting it on GitHub. Make it private. Putting it on GitHub is all right as long as the repo is private. Otherwise, keep it on your own machine after the submission date, after the penalty date is ended. You can put it on GitHub, it's up to you. But as long as the students are still allowed to submit, please keep it private, whether it is on a private repo or on your own computer. Any questions about how we're gonna do the course in general? Yep.
Where are the tutorials?
So tutorials, unfortunately, are not gonna be done in this offering. Why? Because something went up and someone made a mistake, which is not me. So they copied the course structure of last term, which when they didn't have tutorials, and hence I'm stuck without tutorials. So what I've done to compensate is that we made the lab activities as much as possible self-explanatory. So you're gonna go through the lab activities, and you can do it on your own time. And we have consultation labs. So if you're feeling stuck in somewhere, you can't do the activity, you can come to the consultation lab for support. But there's not gonna be step-by-step guidance as a tutorial for these activities. So you do it on your own time, come to the consultation lab if needed. Yep.
Do labs count marks?
So the activities in general are very related to to your assignment. So doing the activities can give you very good chances in doing the assignment properly. The activities themselves are not marked unless you do one of the things I mentioned in the bonus part. So you will get the bonus mark. But the activity itself, it's not marked. But I encourage you to do it because it will simplify your life, make your life much easier when the assignment time is due, because it's closely related. So definitely do it, whether it is marked or not. No, it is not marked. Yep.
Does this course have any career-related opportunities or paths you know?
So opportunities in what terms, sorry?
Career-related.
Oh, yeah, so unfortunately we don't have any, let's say, sponsor coming through in terms of providing any rewards or competition in this regard so far. But we're working on finding some organization that can support us to add a level of, say, reward for the best performers. But currently, nothing related to this. We're going to talk about career opportunities and why data services in a bit, but there is nothing concrete that we can offer you, unfortunately. Any other question? Okay, so let's take a 5-minute break, and then we get some information about the material and what's data services, why do we need it, and so forth. Okay, we're gonna start again. Okay, excuse me. We're gonna start the lecture now. So if you may be quiet, please. So again, if you are interested in being on zThings, link zthings.com/Morty. And let's get going. So you'll notice that throughout the course, I hope that zThings has improved things, but sometimes they fail me, unfortunately. So there is a love-hate relationship between me and zThings. Sometimes I upload something and then just say, sorry, it's not you, it's us. I don't know why they do this. Hopefully this offering, they have improved things because I reported many times. Yep.
Can they be downloaded as just raw files, like PowerPoint or PDF slides?
Oh, yes. I'm going to put this is a really good comment. I'm going to put the slides before the lecture on WebCMS. I forgot to do it this time, but rest assured that before the lecture, you're going to find the lecture slides in WebCMS in the lecture section.
Okay, so zThings is just...
zThings is now because sometimes I put polls, ask questions, and you can also go through the slides one by one if you want online. But in general, the actual PDF file for the slides are going to be in WebCMS. And again, as your classmate here give a comment, really good comment in the regard of the lecture slides, feel free to, if at any point you have some suggestion, comment, feel free to just raise your hand and tell me what it is. I encourage any improvement or any feedback. So I don't want you to wait till the end of the term, in my experience, and tell me now so that I can improve this offering so that you benefit from the improvement rather than the next generation. Definitely they will benefit, but why not you as well? So if you have any suggestion, feel free to come forward. I'm more than happy. If it is something that I can do, I will definitely do it. If it is not possible, I will tell you the details of, okay, why this is not possible now, if anything is holding us back. So, but please feel free to come forward with any suggestions. It's more than welcome. So now we're gonna go through an introduction for data services. Just giving you the feel of what's data services, why data services, what's previously being done, what's now is being the hot topic, and why. So what is data services? So the what part, it's like for data services they are software services that can help encapsulate operations on top of the data. So you have some operations on the data like adding new data records, removing data records, editing, rather than you create something to do, like you create an application that do this online on the data. You create a service that allow not only consumers, high-level consumers like the application users, but also other applications to do these operations on your data sets. So it's on the level of, okay, I'm not allowing the consumption of the data by only high-level consumers, users, but okay, I'm targeting users who might be also other developers who create their own applications. So they can utilize my service in order to build a user interface on top of that and then provide it to their own consumers and so forth. So here with the service level is that it's your customers are actually software developers than high level and consumers like customers, use application customers or application consumers. So this is the service part. So we're looking at a service that would allow other applications or other services to manipulate or to do operations, some operations that we permit on the data using our service. So, okay, why we do this? Like, why do I create a service? Why do I allow this? So recently it's been like very, let's say, interesting or hot area in terms of, okay, you allow other systems to work with your data rather than locking your data set to be used only by your application. And you might have already experienced this if you have done some software development in terms of, okay, you can use APIs provided by Google, like for Google Maps. You can use YouTube API. So YouTube already is providing you this, like you can watch videos on YouTube, but in addition, you can use YouTube API to extract these videos, to extract descriptions and so forth. So it's not only offering you the video viewing application, but also providing you with a service that you can consume through another application. So a lot of applications already utilize data from YouTube, utilize data from Google Maps in order to provide their own version of the experience. So this has been very successful in the space of services in general because it allowed multiple services to be composed together. So rather than, okay, I'm restricted with only using the YouTube platform, no, now I can build another platform or build another application on top of that to enrich the user experience, to add more features, to add an additional feature that's not currently available, and so forth. So in essence, it is increasing YouTube value, and at the same time, it's allowing others to benefit, third parties to benefit. So currently, there are a lot of data sources. So there are data, you can find them as data dumps, CSV files, on websites, and you can utilize all these data sources, consume it, and then pre-prepare it or work on this data, keep what you want, dump what you don't want, in order to provide to your own consumers another version of things. So here it's like you are rather being restricted that the data only reside in these silos. No, the data now is available for consumption, and this consumption can be on the level of other services using this data to build another application and so forth. So this is like in terms of data services, the service component to allow this, and then the availability of not being restricted with a certain data set, consuming this other data from different sources, integrating them to increase value, and so forth. So let's go deeper in this regard. Who knows what this is? Almost, yeah?
The Babylonian ones.
Exactly. So this is the essence of data recording. Let's start with, oh, not that deep. So we start on this layer. It's more like you can relate easily. So in general, this is an example of a general data system. So as you can, like already, if you have built any kind of system, you might have some variation of this. So there is an application that being consumed by someone, whether it's through an API or user interface, and there is an application code that you develop. This application code access a database, a primary database, where you store the important things like the usernames and the data, the bits and pieces that you want to offer. So what is it a weather app? Is it a student record app? All the important bits are stored in the primary database, which could be cached somewhere if it is more frequent. And then, so mainly this is like your standalone. It could be, you can have, let's say, if it is, let's say, a student record application or something related to student, you can have some search feature, full text. You can have indexing there in order to find the records more fast according to, okay, looking for courses according to the tags or the name of the courses and so forth. And also, like, you might have some additional task, asynchronous task, like notifications via emails you're sending to someone. So it might be some queue sitting somewhere in order to send this notification or receive this notification. So in general, this is a simple application, general application architecture. So there is application code, there is a database, there is some caching for requests, there is some interaction, maybe searching, and there is an external interaction that's sending email, sending notification, and so forth. So this is like the simplified way of looking at these applications. So, but like when you're looking at information systems, you might come across the like system integrations, because like it's not always that everything you need are sitting on your primary database. Sometimes there are things that, okay, I want student records that's maintained by another service or a third party. Like you want student records for UNSW student, which is maintained by UNSW. So in that regard, okay, how can I get these student records? Do they have an API? Is there a service I can consume? Or do they have this data as a dump I can download from somewhere? So there is always this need to, okay, my application might need to interact with another application. So there need to be some sort of integration between your application and another and another and another. So this always like has been motivated by the need of businesses. So businesses are growing bigger and bigger, and everyone wants to provide the best user experience. So rather than you have more than one application and you are interacting with them on a standalone basis, they try to integrate with each other so that they can keep you on their platform. So let's say if it is a travel planning app you're working on, and then rather than you say, if you want to check the weather, go use another app. Say, no, I don't want to do this. Can I get the weather information on my app? So that someone who's planning their trip, they can say, okay, yes, I want to go here and there. Oh, is it raining? So I better go to a museum. Is it sunny? Yes, I can go to the beach. So you try to fetch the information needed so that as much as possible you maintain the user on your platform rather than you say, yeah, for weather information, please go to this application. And then they leave your application to go somewhere else, which will make the things not very convenient. Also, like in other regards, so there are integration, the purpose of maybe company mergers. So we've seen a lot of mergers, like WhatsApp is being bought by Facebook. This is being bought by that. So there are many mergers that's happening, and organizations need to make sure that, okay, we've bought this company or we've merged with another company, rather than we have two standalone separated data sets. We need to think of how we can integrate them, how we maintain the same user base, how we can maintain providing similar services for everyone. So integration also important on the side of merger between organizations, how they can merge their data, how can they integrate their data together, how they can also integrate their business processes together so that they still provide similar services for their whole user base. So when it comes to integration, it's not as easy as is, because it has many complications. So because sometimes organizations, they develop their own ad hoc solution. So there is legacy systems that developed for the sole purpose of this organization. So when you're thinking about integration, then you need to build a whole new system that can work with their data. So sometimes, like, organizations use off-shelf solutions for this, which also sometimes is not very easy to handle or like easy to interact with. So integration is not as easy as you wish it to be. So according to what's available, you need to think, what's the possible solutions? How can I integrate data from multiple sources? How can I allow the consumption of this? We'll look at some solutions that previously existed and what's the relation, why we have come to the level of services now. Because previously, the notion of services was not very popular, like was not existing actually. But once people started looking at the benefit of having services, they found out, okay, yes, it makes our life much easier, and we should create everything as a service. We're gonna look at how and why. So when it comes to integration, previously you have levels of integration, two levels, either system level or data level. On the data level, the problem is that, okay, we have, let's say, multiple databases. So I have a data source number one, which is shipment order database, which have this schema. I have another database, which is the customer relationship management database. So it has information about the customers and it has this schema. And then I have my pricing data. So I have another database with a different schema. So when you're thinking about providing a wholesome solution for your customers, then you need to think about integrating these three data sources together in order to provide this useful service for your customer. So it could be on the level of data integration. So you create a new data set that map all these schemas together and you maintain them on this new integrated order database. So it's a new database. Either you do this physically or in a virtual way, but nevertheless you need to create this database that can pull the data from these data sources and provide it in the application to the users. So on the level of data integration, it's this, just like you're trying to map everything together in order to give to the users. So either this on like you actually creating the physical database, or you can have the data level integration on the view-based data integration. So you create wrappers that what they are doing is on the fly, when the times come when someone make a request that involves the data set from these multiple data sources, the wrapper is going to do is like on the fly, it's going to access this database and provide you with that piece of information that you need to have a mediator that glue all these bits and pieces together in order to serve to the consumer. So in this sense, you need to have multiple wrappers, a wrapper for each data source, which can take the information on the fly, and then a mediator glue them together and say, hey, here you are, this is what you asked for. So this is like the solutions that like existed in the data integration space. So when we're thinking about data integration, we have two aspects that we need to pay attention to. So there is global as a view. So looking at the new data, the new global data scheme as your way of viewing the data on these separated data sources. And there is a local as a view. So this is like the other way around. So I look at the data from the perspective of the local, these separate three data sources, in order to generate the answer to the query that the user has initiated. So this generally what the organization have been doing previously into data integration. So they specify, do I dump the data physically? Do I create the data? Do I have a global as a view? Do I have a local as a view? And then try to create the, put the answer to the query back so that the consumer can use it. So as you might notice that it's not an intuitive and easy way of handling the data from multiple sources. This had been like a lot of organizations, when they come to the level of integrating data, when they do mergers, it's a total nightmare because there are a lot of things that they need to consider, different schemas, different data sources, and they all need to pre-process them in order to maintain value for the data that they have. So like you might came across the notion of data warehouses. So with data warehouses, it's similar to what we talked about in regard to data integration, that the data sources is actually being loaded to the data warehouse, and then you query the data warehouse itself. And while on the other hand, the mediator or the global schema solution is now relying on data wrappers, and the wrappers try to map the query of like the original query of the user through the mediator in order to see, okay, what wrapper should query which data source in order to gather these bits and pieces. So this is the virtual integration with wrappers, while the materialized, the physical with loading the data is the data warehouse itself. So this is like how some organizations are still doing this. I'm not saying that it's completely overthrown, but still it's not really an intuitive solution, because if there is a new data source generated, if there is another merger, then you need to redo everything, and that's a bit of a nightmare for organizations, especially big organizations. So this is a data level.
What's an ETL again?
It's what's the stand? Extract, transform, and load.
And what's the merits and demerits of, can you go over that again, of using both the systems? Why would you prefer one over the other? And can you give examples of wrappers and mediators?
So for both data integrators, as I mentioned, so here you need to actually map the request. Like someone is asking about a shipment order, saying that, okay, when this shipment order is due, or like when it will be delivered, or what's the cost. So on the level of data integration, let's say for the first solution, the materialized. In the materialized, the data sources from multiple data sources, like the first one is shipment, the second one is billing, the third one is customer relationship management system. So you need to already load this data in the data warehouse. You need to already do the manual work of mapping all the information together, and then the user can query it. So there is a lot of effort in order to do this mapping that the organization need to do itself in order to be able to query the data from these multiple sources. On the other hand, the virtual integration. So with wrappers, there is no actual loading, but what you need to create is wrappers for each data source that on the fly, when someone is querying a specific order, the mediator is going to decide which wrapper I need to query in order. So I need the, let's say, the customer relationship information, and I need the shipment, because these are the bits and pieces and that being queried. So the wrappers are going to provide this information, and then the mediator is going to, let's say, express them in a way that the requester wants them to be. So here you need to have the effort of creating a specified wrapper for each data source. If you have a new data source, then you need to have a new wrapper. And then you need to also configure in the mediator how you can access this wrapper. So also, this requires an additional effort of always having a manual phase of creating wrappers, creating how this mapping needs to be done so that the mediator can actually access the data. As I mentioned, it's not a solution that's not being used currently. Some organizations do use it, so they find still benefit of using this, one of them, whether they materialize with data warehouses or virtual with wrappers. They are still doing that. But nevertheless, when we're going to talk about the services, you'll find the difference of, okay, how much easier to provide this data as a service. And then when we're talking about adding a new source, it's much easier rather than doing mapping, creating specified wrapper, and then do the mapping through the mediator in order to extract information. So the rationale why I'm giving you this is that I just want you to understand how it's being done so that you appreciate the existence of services, why there is services, and why it make our life much easier.
So say you have different sources, right? So say you're pulling data from a SQL database, you're pulling data from a text file, you're pulling data from a CSV file, right? What would be an example of wrappers that you'll map the shit to, and what would be a good example of a mediator that is like a global schema for all these wrappers?
Yeah, so in that regard, like, let's say even if they are all SQL databases, it doesn't matter as long as they have different schemas. So you need to say, okay, for the first wrapper, if the schema and the first data source is that they use, let's say, like date of birth in a specific format that's not being used, not the same format in a different one. So they use month as a characters rather than number or so forth. So when you're doing this integration, you need to have the wrapper, like the mediator, sorry, the mediator need to understand the difference that Jan is 0, 1. So rather than, okay, not understanding what we are doing, the mediator already need to understand, okay, what's being stored here and what does it actually map. Sorry, yeah?
As he asked it for a real-world example, would you say that Tableau and MicroStrategy as reporting systems are a mediator system because you can connect like Excel files and SQL databases and other databases into one system, and when you create a dashboard or an analysis, you can actually map like things from the Excel file to the things you got from the SQL database and combines them to one dashboard? Would you say this is?
Yes, so there are many ways of expressing this. So this is one part of, okay, if you have one spreadsheet that have some bits of information, and this spreadsheet have some, let's say, user data that's mapped to data records or like user records that's being stored as a SQL database. So you need to do the actual effort of, okay, understanding, is this the same user? The name is the same, the date of birth in a similar format, the ID of, let's say, if you're looking at passports or looking at student ID, what do you need to take as like the key that you can rely on? So the mediator need to handle this in order to be able to extract the data and combine the bits of information to provide to the user as the result of the query. So it's not something that's not being done currently, but again, I want you to understand what's being done here in terms of effort versus what we're going to explain as a data service, and you appreciate how data services simplified our life, like as a developers.
So is there no like whatever standardized method, or like no, is there no method and no architectural method to standardize all these data sources such that they're all in the same format? You know what I mean?
So like in terms of everything mapping exactly to, if you have a formalized method that as soon as you plug in a spreadsheet, it will convert it into another format. Even if it does that, as I mentioned, the problem is not the types is one problem, but the second problem is the schema. Because it's like you need to make sure that the schema is relevant. They can match on some level in order to give you the results of the answer. So there is no system that can look at this on the fly and decide, yes, this is the same person, or no, this is not the same person. You need to do that actual effort yourself, and hence create, if you're looking at global as a view schema or local as a view schema, you need to do the mapping yourself. It's nothing gonna give it to you as ready as, okay, you can use it, just plug it in, and voila, it is working. So on that level, it requires effort that's much more simplified with services, as we will see. Any other question? Okay, so this is data level integration. Then people started thinking, okay, if I have these systems sitting around, like if the billing department already have a system on their own, if the shipment department already have a system of their own, the customer relationship management has a system on their own. So the idea of integrating these systems can help us with providing a higher level service that can be used by the customer. So rather than I collect the data, as we've seen in the data integration, now we're thinking about system integration. So the systems are going to be talking to each other. So the billing department and the shipment department and the customer relationship department and so forth. So their systems are going to talk to each other in order to provide you with the service. So it is a system integration in that regard. So these silos are sitting in these departments, and then we try to make them talk to each other in order to provide the valuable application, like the query, whether the user, what they want to do, or in order to fulfill a business process, what need to be invoked from multiple services. So for the system level integration, you can think about it as this. If you look at the typical purchase order process, so there are some subtasks within this process. That's okay, the customer need to make the purchase order, and then after the purchase order is being made, you need to be sent to the, let's say, the storage department to identify, do we have inventory? And then you want to send it to the customer relationship to identify, do the user have account with us? Do we need some information about his banking details? And then you look at supplier of how we can deliver, shipment in terms of how we can deliver the product to the customer. So as you can see, like within this purchase order, there are multiple interactions between different systems. So each one of these departments have the system of their own, and then they want to talk to each other in order to be able to fulfill this business process of giving sending the shipment to the user and receiving the payment from the customer so that they can fulfill this business process of purchase order. So there is multiple interactions between these two, many different systems. Each system is a standalone, so it's a silo by itself, have its own database, have its own schema, and so forth. So how we can actually make them talk to each other? Previously, like you can look at, they looked at it from the perspective of specialized system-to-system interaction. I make a messaging queue that's specifically made for these two systems that I have in-house. They can talk to each other. So it's a possible solution this way, but again, when you're thinking about expanding or adding additional, there is a new department, saying the compliance department, who have their own system, who also need to read from this and understand what's being happening. So the thing, flexibility is when it is restricted, when you create a specialized proprietary interaction channel is limited when we're talking about this one. So that's why it's being, when we're talking to system-system interaction, we'll see that how services simplify this in that level. So rather than creating a specialized system for each of these departments to talk to each other, the services can have this uniform way of interaction that make the life of the software developer who created the system to fulfill the purchase order much easier. So, and again, when we're talking about, this is like the typical purchase order, but even when you drill deeper and you look at the real life purchase order, you see that the interaction between these systems is not one way. It's not like one time interaction. Sometimes there is verification, missing information, resend. So it is more into, sometimes the interactions become very complicated, the communication become more spaghetti-like communication, which will affect the complexity of the system. And then sometimes purchases or purchase orders or billing information are lost here and there when we're talking about creating proprietary communication channels between these departments. So when we're talking system integration, they started to have a need for a more formal or uniform way of interaction between systems to make sure that, okay, as much as possible, I know that all my systems are using, say, a REST API for communication and so forth. So we're looking at the system interactions through services in a bit. So the main purpose when we're talking system to system is that, okay, you have your own fantastic application. I have application for travel planning, and standalone, I have information about what destinations and what attractions there is and so forth. But I have a need of other information outside of my system. So I need to interact with someone else's fantastic application in order to add value to my application. So I want to add some weather data, which I do not maintain in my application. So I need to interact with another application that's specialized for weather information, weather prediction, what's happening, so that I can cater my customers all the information they need in regard for their planning of their trip. So I give them the destinations, reviews, and so forth, and at the same time, I can give them a recommendation according to the weather. It's raining on this day, so better you find something indoor. It's sunny on this day, it's relatively warm, so you can go to the beach. So rather than just restricting according to some localized data, you can interact with someone else's application in order to enrich your own application with additional information, add more value. So you need some sort of messaging, because how these two systems works, how these two systems talk to each other is something like naturally does not exist. So you need some sort of way to cater this. So in general, like the evolution of how we reached services, the motivation is that you want some two applications to talk to each other. The evolution comes from, okay, previously within your own system you have functions and procedures that call each other. Then we created models that talk to each other, objects that I can transfer from one model to another. I have programming components. And then when we reach the level of the internet and the web, and I have my own website online, and I want to have as much users as possible. So the communication media is the internet. So it's relative to have some form of communication channel that can help me communicate with these these different systems. So using services, and specifically web services. So rather than you create proprietary communication channel, no, I can create something, I can utilize something that's more like general purpose. So a way of communicating between different systems through web services. So web services is on the level of, okay, after multiple evolution of programming abstractions, from simple procedures into, you can think about it, services as a procedure you call online. So you're interacting with the system through a mean of utilizing web services to extract data or to invoke a specific feature in someone else's application. So in general, like, this is more of an architectural style. Service-oriented architecture is not something that, it's not just only communication channel, because previously it started this way, that I want to communicate with someone else's application. But now it's more like, okay, even within my single application, I create internal services that can communicate to each other. So my module, my internal modules in my system, they actually utilize web services to talk to each other. And hence I reap the benefit of, I can provide multiple, let's say, these specific endpoints to even externally, so that the users use it. So this is more related to the notion of microservices, which if you are interested in, you can take Comp 9322, where we go through microservices in details. But in general, what I want you to appreciate is that it's more of a way of you architecturing your system, that these services internally, even if you have it in a single platform, that they communicate with each other using web services. So the service-oriented architecture is more the lens of how you look at these services working to each other. So what the services is in general, rather than like I talked previously, I mentioned REST API. REST API is just one way of communicating, or like one way of creating a web service, but that's not the only way. So, but in general, what it is, it's a form of contract of how these different systems or how these different components talk to each other. So what do I need to do in general to invoke a specific service? So let's say in the area of RESTful API is that you're gonna use HTTP method. So you say get, let's say user. So you are using a uniform way of interacting. So you're telling it you're using HTTP method, which is get, which is known to everyone. And then you're specifying a resource. You're specifying what do I want to access. So I want get user and I provide ID. So I'm getting that user. Think about it as you're doing a SQL query, but rather than you're on a database, you're on the web and you're accessing a service to get the information of the employee or the student on the system. So this is more like it's just a formal way of defining the contract of how you can access the data. And the beauty of services is that, okay, you can chain multiple services together. So you can access the student data service in order to get a student record. And then you can access the, let's say there's another service called course service, which can give you the capacity of the course. Do we have space that a student want to enroll? So I get information about the student. I have the information about the course, and I can say, okay, they want to enroll, so I can increase, occupy one person in the capacity in order to indicate that the student has enrolled. So you have multiple services that one can invoke each other in order to do some requirement that the user want to do. What do they want to do? They want to enroll in a course, so they can pass their information from this service to this other service, and hence you can, just like you're composing, you're putting two Lego pieces together in order to build something bigger. I want to enroll in a course. I want to review a course, and so forth. So the beauty of services is that, okay, each component is going to be standalone, and you can just put them together in any way you want in order to get a better value or more value for your application, what you allow the users to do. So the service composability is really attractive in this space. It's more like a general way of how these smaller services can be put together in order to generate something of more value to the users. Yeah, so this is like in terms of what is the service, how you can compose a service. So you can think about, okay, what I give the example of the trip planning service. So this is like your main thing is trip planning, and you have some information about the destinations, the attractions, and so forth. You access another service which can give you the weather. You access another service which can give you booking. Like you see here, someone decided that they need to come to Sydney on this day, on this week, and then you're telling them that according to the weather information, it is raining, maybe you want to go to a museum, and then you use a booking service for the museum, so someone can actually buy tickets to go to the museum, and then they can use another service to plan a route. Okay, you need to get on this bus, on this train, in order to arrive there. So all these services composed together can add more value. So rather than the user need to go themselves and then do the booking or do the trip planning in terms of what do they need to go in, which bus, which train, they can do all this in your own application. So you keep them on your application, which is like mainly the ultimate goal of all developers, is that I maintain the user on my platform as much as possible rather than pushing them away, go purchase using another service or go do the trip planning on another service and so forth. So composing these multiple services together can help provide more value for your application and maintain the user on your application as much as possible. So for each service here, like when we're talking about this trip planning application, when it's invoke another service, like the weather service, when it happens, the trip planning application is the customer, is the consumer of the data. So the trip planning application is consuming the data from the weather application service. And it is consuming information from the booking service. And it is consuming information from the transport service and so forth. So for each level, when a service is invoking another service, one is being the provider. So here, this is the provider, while this is the requester. On this level, this is the provider, and this is the requester. So the services themselves are requesting the information. It's not on the level of user, because here we're talking service system talking to another system, rather than users doing everything by themselves. Any questions about why services? Okay, so like in that regard, we understand that for allowing systems to integrate, to talk to each other, services is a good idea, rather than doing that on an ad hoc, proprietary way. If you create some formalized way of two systems talking to each other, then it makes your life much easier. But now, why data services? So if you look at it from job perspective, data services, data science currently is a really sexy job. So as mentioned by Google's chief economist, it has been predicted that data science and like working with the data and publishing the data, allowing the consumption of the data, is going to be even more and more attractive. So some people think that, okay, that's probably not happening, but as nobody has predicted that computer engineers in the 1990s is going to be a sexy job. Currently, data service engineers and data scientists are being the sexiest job now, because we have more data, we have more demand from consumers to use or consume this data. So it is essential to have this way of interacting between two different systems and getting this data and then providing more value to the consumers, to the users on the high level. So data is popular. So if you look at like here in terms of trends, so you can see that, okay, when we look at trends for interests in terms of data science, Internet of Things, and machine learning. So you can see that there is an increase from 2009, 2015, 2019, that there is a steady increase in these terms. People are interested in data science. People are interested in Internet of Things. People are interested in machine learning. All this, actually, when you're thinking about machine learning, data science, and Internet of Things, they are the components of data services, some components of data services. Because like when we're talking Internet of Things, it's one of the sources for data, machine learning, analytics on data. Data science, analysis of the data and preparation of the data. So you can see that there is a steady increase in interest in these things. Definitely it's like when you're looking at comparing according to the interest with other things, they may pale out, say, oh, they are not actually interesting, but that doesn't matter because like who's interested in data science and machine learning and IoT? There are definitely more developers rather than the general user space. So definitely like don't try to compare it with other things but in general, when we're talking about comparing between each other component, there is a clear steady increase in interest. So like even when you compare it with another component like quantum computing, you can see, okay, yes, quantum computing, there is an increase in quantum computing, but if you compare it with Internet of Things, machine learning, and data science, these guys are more dominant. So why there is an interest? Because data is valuable. So we can see that there are many organizations, they capitalize on data. So their bread and butter is data. So Facebook, they rely, like when we're talking Instagram, when we're talking WhatsApp as like data sharing platform, their main thing is how they can allow the access of data, the transfer of data, the communication channels. And then they are really valuable in this space. So they do not have physical assets. Their asset is data. Facebook, Google is the same in terms of IBM, similar things in terms of services for data analytics and so forth. So there are a lot of companies, they do not have physical assets. Previously, let's say 20, 30 years ago, the companies who did really good in industry were companies with big assets, like infrastructure companies, oil companies. But now it's more like the people with data. So data is becoming the oil of these days. And data is massive. So there is interest in data. We can see that people are interested in data. It is valuable. And now it's being generated in like massive amounts. So we keep posting on Facebook. People are keep taking photos on Instagram. So the data is generated in a rapid way and in a huge amount. And that's also put the requirement of, okay, how we can handle the data, how we can use that data. Because it's not useful for you, like I have 10 petabytes of data. If you're not doing anything with them, then they are just holding you back. They are just cost. But if you analyze them, understand what you can do with them, then you can make profit out of this data. So data is being generated and in a huge amount. Unless you know how to work with that data, how you can benefit from it, it's just cost. So this is like just giving you on every minute how much data is being generated on different platforms. So as you can see, like this is every minute. So the data is being accumulated in huge amount, and now the need for data service engineers is even increasing more and more. How we can make use of this data, how we can profit from this data. So just like in terms of data sources, where this coming from. So there is, like, in terms of internal data sources, could be transactions in a company, log data, emails. On external part, you can say, okay, this is more social media, audio, photos and videos. So data coming from within the organization, external from the organization, different types. All this require that there is a dire need for data service engineers to be able to handle this data, pre-process them, analyze them on the level that they can generate profit in this regard. This is another example of where this data coming from. So from computers, mobile phone, tablets, gaming devices, and so forth. And like one of the things, that's why I mentioned IoT is being one of the like related topics to data services and data service engineering, because IoT devices, sensors, they keep generating data. So say a lot of organizations, they have thousands of sensors that they keep generating data unless they know how to handle this information, this huge amount of information being generated, and how they analyze it, identify, okay, these sensors on different platform, on different machinery, is this machine is going to break down? Do I need to do maintenance? Do I need to send someone? So they need on the fly to be able to analyze this data and make decisions according to this. Here, data analytics become really important because you cannot have someone sitting there and looking at every sensory data and decide, hey, I spotted the problem. No, you need some way of automating this. So data analytics and machine learning tools are important in terms of handling the Internet of Things data. And like everything is now connected. So this is more like services. Everything's connected to each other. You need to know how this connection is happening, how the data is going back and forth, and how you can manage this data to ensure that you add value to your organization. And like another example of how the data is increasing and the prediction of even more increase of the data being created. So like you can see in 2025, it's predicted to the amount of data generated is 160 zettabytes. So that's even like phenomenal amount of data is being generated, and that data need to be handled somehow in order to be useful to generate something. So I give you some example in terms of what we can do with data. So life sciences, they collect data about like general information about whether it's what the users are doing, they have multiple let's say sensors, health sensors that they are using in order to monitor some patients, in order to monitor the health of the patients and so forth. Banking, they generate lots of amount of data from transactions, from the purchases for the customers. They can monitor who's doing what, and even like looking at from fraud perspective, like is this person actually doing a transaction in Thailand, or is he actually still in Australia? Fraud, yes, let's flag it, and so forth. So the data is there, but unless you have some way of analyzing and detecting any abnormal activities, it's useless. Manufacturing, let's say here in mining area,